What if everything you've known about the universe could be explained by tiny, vibrating strings? Quite a thought to chew on, isn't it? Welcome to the fascinating world of string theory, a theory that has the potential to be a theory of everything. You see, our current understanding of the universe is governed by two major theories: quantum mechanics and general relativity. Quantum mechanics rules the microcosm, the world of particles so small that they're beyond our sight. On the other hand, general relativity governs the macrocosm, the vast expanse of the universe, from stars to galaxies and beyond. But here's the hitch. These two theories don't play nice together. They're like two kids in a sandbox, each insisting that their way of playing is the right one. That's where string theory comes in. It's the peacekeeper in the playground, the one that says, "Hey, you two, we can all play together nicely." And it does this by suggesting a simple yet profound idea. What if everything in the universe, from the tiniest particle to the grandest galaxy, is made up of tiny, vibrating strings of energy? To visualize this, imagine a grand piano. Each note that the piano can produce is like a tiny, vibrating string. Each string or note represents a different particle. Now imagine playing a symphony on this piano. The symphony, with its multitude of notes played in harmony, represents our universe. It's a grand orchestra of strings, all vibrating at different frequencies, creating the cosmic symphony we call reality. So, in essence, string theory is our attempt at composing the universe's grand symphony. It's our way of making sense of the cosmos, of finding the common language between the micro and the macro. And while it's still a theory, still a melody being composed, it's one that might just help us understand the deepest mysteries of the universe. Now let's dive deeper into the world of strings. Imagine, if you will, a universe where everything, from the tiniest particle to the largest galaxy, is made of tiny strings. Welcome to the fascinating realm of string theory, where we replace the idea of zero-dimensional points that make up the fundamental particles of matter with something a little more spaghetti-like. Yes, you heard right, spaghetti. Imagine for a moment that these fundamental particles are not just dots, but one-dimensional strings, similar to a piece of spaghetti. Now you might be thinking, what's so special about a piece of spaghetti? Well, it's not the spaghetti itself that's important, but rather what it represents. In string theory, these tiny strings are the most fundamental building blocks of our universe. But these aren't just any strings. They're more like the strings on a guitar, each one humming with its own unique vibration. The different notes that these strings play are what give rise to the diverse particles we observe in the universe. The quarks, the leptons, the bosons, all these particles are like different notes played on the cosmic strings of the universe. The melody of the universe, then, is composed by these strings. Each string vibrates at a different frequency, just like each string on a guitar plays a different note. And it's this symphony of vibrations that forms the basis of everything we see and experience around us. If this sounds a bit like a cosmic concert, you're not far off. Each particle, each force, is like a note in this grand symphony, played by the one-dimensional strings of string theory. From the lightest photon to the heaviest black hole, everything is a part of this universal orchestra. So, just as a musician can create an infinite number of melodies using just a few strings, the universe creates an infinite variety of particles from these tiny vibrating strings. But how do these strings shape our understanding of the universe? We'll dive into that in the next scene. Stay tuned and keep your ears open for the Symphony of Strings. Have you ever wondered why we only experience 3 dimensions when string theory suggests there could be many more? Let's dive into the concept of extra dimensions in string theory. When we talk about dimensions, we're not referring to alternate realities or parallel universes, although those are exciting ideas. No, we're talking about spatial dimensions, directions in which you can move. Now imagine an ant walking along a garden hose. To us, the hose is a 2-dimensional object, length and circumference. But to the ant, it only experiences one dimension, the length along which it walks. It's oblivious to the other dimension curling around the hose, the circumference. This is because the circumference is so small compared to the length, it's virtually unnoticeable. In string theory, our universe is like the garden hose, and we're the ants. The theory proposes that there are additional dimensions, possibly up to 10, but we only experience 3 spatial dimensions and 1 time dimension. The rest are curled up, so infinitesimally small that we can't perceive them. But why would we need these extra dimensions? Well, they could potentially explain phenomena that our current understanding of physics can't, like dark matter. We know it's there, we can see its gravitational effects, but it's entirely invisible to our current detection methods. Just like the ant oblivious to the circumference of the hose, we might be oblivious to these extra dimensions where dark matter exists. Now, you might be thinking, extra dimensions, tiny strings, ants on hoses, this is getting a bit wild. And you're right, it's a bit like trying to understand a joke in a language you don't speak. But that's the beauty of string theory. It challenges us to think beyond our everyday experiences, to imagine a universe more complex and intricate than we ever thought possible. So we've got tiny strings and extra dimensions. But how does this all come together? Well, we'll explore that in the next scene. Stay tuned. What if I told you that these tiny strings might be the key to understanding the very fabric of space-time itself? Now, that's a thought to get your neurons firing on all cylinders, isn't it? To understand how string theory could potentially explain gravity, let's bring in a familiar analogy. Imagine a trampoline. When you place a bowling ball in the middle of it, the trampoline fabric distorts, creating a depression. This is similar to how mass distorts space-time. Now, picture this. In our universe, the fabric of space-time isn't a flat trampoline. It's a complex, multi-dimensional tapestry woven with these tiny, vibrating strings. The mass of an object like our bowling ball is determined by the vibration of these strings. When the strings vibrate, they cause distortions in the space-time around them, just as the bowling ball distorts the trampoline. This is what we perceive as gravity. But the strings aren't just distorting space-time, they're an integral part of it. They're the threads that hold the tapestry together. They're the notes in the cosmic symphony that create the melody of the universe. Each string's vibration is a note, and all these notes together make up the music of the cosmos. Isn't it fascinating to think that the universe might be a grand orchestra, with each string playing its part in the symphony of existence? The universe isn't just empty space filled with celestial objects, it's a dynamic, vibrating entity, and every vibration, every note is a testament to the existence of these strings. But remember, as with any scientific theory, string theory has its critics. Some argue there's no concrete evidence for these strings. Others say the math doesn't add up. But that's the beauty of science. It's a constant journey of discovery, of challenging ideas, and of pushing the boundaries of our understanding. As intricate as a symphony, as mysterious as the unseen dimensions, string theory continues to push the boundaries of our understanding. Every note, every vibration, brings us one step closer to deciphering the cosmic score. So where does string theory go from here? What does the future hold for this symphony of strings? The future of string theory, like its strings themselves, is both tantalizing and elusive. The theory has faced its fair share of challenges, each one a note in the grand symphony of the universe. One of the key hurdles is the lack of experimental evidence. Despite its mathematical elegance and explanatory power, string theory has yet to provide predictions that can be tested in a lab. But fear not, this doesn't mean that string theory is down for the count. In fact, it's quite the opposite. Researchers around the globe are tirelessly working on ways to test string theory's predictions. One avenue they're exploring is the detection of extra dimensions. If string theory is correct, then we live in a universe with more than the 3 dimensions of space and 1 of time that we're familiar with. If we can detect these extra dimensions, it would give a significant boost to string theory. The potential implications of string theory are profound and far-reaching, stretching beyond our current comprehension of the universe. One such implication is the possibility of parallel universes. If string theory holds true, we could be living in a multiverse where countless universes exist side by side, each with its own laws of physics. Imagine that, a universe where your alternate self is watching this video, but in a world where gravity pulls upwards, or where time runs backwards. While these ideas might sound like science fiction, they're part of the ongoing scientific discourse, pushing the boundaries of what we know about the universe. As we look towards the future, it's clear that string theory will continue to play a vital role in our quest to unravel the mysteries of the cosmos. It's a journey filled with challenges and uncertainties, but one that promises a deeper understanding of our place in the grand scheme of things. As we continue to unravel the universe's mysteries, one thing remains certain: our symphony of strings is far from over.